Selamat sejahtera everyone. Okay, I just like to remind for the midterm test. Okay, we will held on Thursday at 5 o'clock. Okay, in FKE BK 3. Okay, we'll try in BK 3. Okay, so I will so please just bring your ni lah, apa nama, your stationery lah. Okay. 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 So today we will continue our class. Okay. For the instrument and measurement. Okay. For the DC AC bridge in the chapter 5. Okay. Last week we already finished for the DC bridge. Okay, now we will continue with the AC bridge, and next week we will have a final chapter with chapter 6. Okay, for the sensors and transducers. Okay, so for the AC bridge, okay, so I will make it bigger. Okay, so compared to the DC bridge, okay, the AC bridge is the used for the alternating current, okay, for the alternating current, and you can see in this figure, okay, where the source is AC current, okay, and which can be used to measure the inductance and the capacitance, okay, which can be used for measuring the inductance and the capacitance. Okay, so the design of this AC bridge also based on the Wheatstone bridge, okay, because with the same concept where the detector, we want to balance the value of the right and left of the bridge, okay, to make sure that the detector doesn't detect any current go through around the detector. Okay, so the features of this AC bridge consists of 4 impedance. Okay, uh, impedance means Z1, Z2, Z3, and Z4 on each side. Okay, and AC voltage. Okay, the AC voltage as a source, and also the detector in the middle of the bridge. Okay, so the detector can be paired of a headphone, okay, can be anything. For example, the can be a pair of headphone or Lissajous figure, okay, based on the oscilloscope, okay, and the electronics galvanometer, okay. So detector can be three of these lah. And we want to balance the bridge, and if the bridge is balanced, okay, then you can get this value where this is the same with the Wheatstone bridge, where Z1 over Z3 is equal to Z2 over Z4. Okay, so the right is balanced with the left. Okay, Z1 over Z3 is equal to Z2 over Z4. Okay, just the difference is we need to change into impedance. Okay, but in Wheatstone bridge we only use the resistor R1, R2, R3, and R4. But for the AC bridge we use the impedance. Okay, next, the function of the bridge is to measure the unknown inductance. Okay. Okay, first, AC bridge is a Maxwell bridge. Okay, the Maxwell bridge is used to measure the unknown inductance. Okay, so Z can be from R, and also Z can be from combination between R and C capacitor, and Z can also be from adjustable capacitor, and also with the inductance. Okay, but for the Maxwell bridge, okay, you need to memorize this, where for the Maxwell bridge, this is the configuration of the Maxwell bridge. Okay, where Z1 is R1 is parallel with the C1, with the Z2 is only R2, and the Z3 is adjustable C3, and also ZX is combination between Rx and Lx. Okay, now because after this we will have another type of bridge such as a wind bridge, sharing bridge, and also another one I forgot. Okay, so that's some of the bridge that we will discuss today. Okay, so for the Maxwell bridge, okay, during the balance condition, okay, as we know, okay, from the previous, Z4 is Zx, okay, so we can multiply the Z1 and Zx and Z2 and Z3, then we can have a like this. Z1 Zx is equal to Z2 Z3, okay, then we can find where the Zx is equal to Z2 times to multiply to Z3 over Z1. And Z1, we can change the Z1 into Y, where it can be like this, where Z2, Z3, Y1, and then we can find the Zx, okay? And here, okay, if the Z1, okay, this we already discussed in previous slide. Okay, Z1 is R1 in parallel with C1. Okay, that's why Y1 is equal to 1 over Z1. And therefore, Y1 is R1 over R1. Okay, because it's what call it, contra of the Z, and plus with the JW J omega C1. Okay, so this is the value for the Y1. Okay. Okay, so this is for the Y1. And for the Z2, okay, for the Z2 is R2, okay, Z2 is R2, and Z3 is R3, and while for the Zx is Rx in series, in series with the RLX, therefore we can get the Rx plus JW J omega Lx. Okay, I think this is you have been studied in electric circuit 1 or electric circuit 2, okay, based on the impedance. Okay. All right, so for the Maxwell bridge, okay, we can put all in, okay, Z1, Y1, Z2, and Z3 inside this, okay, inside this. Okay, you can put all this inside this, okay. Okay, all you can put inside this, and we can get this, okay, where and Zx is here lah, okay. So when you put all this Rs plus J omega Lx equal to R2, R3, okay, R2, R3, where Z2 and Z3 is multiplied, okay, times to 1 over R1 plus J omega C1, okay, you can get this lah, okay. After you get this, okay, you can times, okay, you can times it and you can open the bracket and you can get like this lah, okay. So you can get R2 R3 over R1 plus J omega C1 R2 and R3. Okay, so here you can get one simple equation for the Maxwell bridge. Okay. Next step. Next one. Sekejap. Lain pula annotation ni dia keluar. Save. Sekejap. Aduh, macam-macam pula ni. Macam mana keluar ni? Oh, lain pula. Okay, so after we get the Rx plus J omega Lx equal to R2, R3 over R1 and J omega C1, R2, R3, okay, we can make an equation between the real term and the imaginary term. Okay, based on the Wheatstone bridge, okay, we can define, okay, which one is real term and also the imaginary term. Okay, so in this equation, we can see the real term is R2, R3 over R1, while for the imaginary term, which here you can see there is J and J, okay, this is imaginary term, okay. So we can know that the Rx is equal to R2, R3 over R1, and the Lx is C1, R2, and multiply with R3. Okay. So in this case, okay, the we want to also find Q, okay, Q, which is the power quality factor, okay, which is can be get from the omega Lx over Rx. Okay, then we can find we can insert the Rx inside and also the Lx inside, and then we can find that the Q is equal to omega C1 and R1. Okay, Q omega C1 times multiplied with R1. Okay, in this Maxwell bridge, okay, the higher Q is indicates the lower rate of energy loss, okay, which is relative to the stored energy of the capacitor. Okay, so it can also represent, okay, the efficiency of the given capacitor. Okay, for example, in electric electric, okay, so normally for the Q will be measured, okay, in order to find the power quality in your house or your building. Okay, that make sure that the capacitor is stored energy in the capacitor and can and the efficiency of the capacitor in terms of energy losses in your house is also guaranteed. Okay, as the ideal capacitor, this will have an infinite value of Q, meaning that no energy is lost at all in the process after storing energy. Okay, so for the Maxwell bridge, okay, the features is basically is to limit measurement for the low quality factors, okay, where the Q is value is between 1 to 10. Maybe after this we will go for the measurement for high quality factors more than for the Q values more than 10, okay, and these fixed capacitors, okay, has the disadvantages that there is an interaction between the resistance and the reactance balance. Okay, so for the capacitor that we use here, okay, have the disadvantages, which is interaction between the resistance and the reactance balance. Okay, then we have some of such as a Hayes bridge. Okay, for the Q high coil Q, this is to measure the high Q coils, okay, for the value of Q more than 10. Okay, So before we go for the Hesse-Bridge, okay, so let's go to the example 5.2. Okay, in this 5.2, okay, a Maxwell bridge as shown in figure 5.6. Okay, 5.6 that we learned, yeah? Okay, is used to measure the inductive impedance where the bridge constant at balance are C1 is equal to 0.01 microfarad and R1 is 470 kilo ohm and R2 is 5.1 kilo ohm and R3 is 100 kilo ohm. Okay, from here, okay, find the series equivalent of the unknown impedance. Okay, so they want to find the ZX lah. Okay, so in this examples, okay, so you have to know the equation, okay, for the Maxwell bridge, okay, where the tak boleh macam ni ya. Dia tak stay dapat ni. Oh, biasa kan. Okay. So, you have to know the equation, okay, for the Rx, okay, and Lx, okay, where the Rx is R2, R3 over R1, and Lx is R2, R3, C1. Okay, so you can find the Rx is, you just put in the value R1, R2, and R3, and then you can find that value of Rx is 1.09 kilo ohm, while for the Lx is R2, R3, and C1. Okay, and you can put inside, just make sure you consider all the units, because here is kilo ohm and here is micro, kilo and micro, and you need to consider it either micro is 10 over -6, right? So and k is 10 over 3. Okay, so then you can get the value, okay, for the Lx. Okay, so please to consider all the units. Okay, for therefore the equilibrium series circuit in figure this is 5.6 lah. Okay, is Rx is equal to 1.09 kilo ohm, while Xx is equal to 5.1 Henry. Okay, so this is how you can measure, okay, for the Rx and Lx. Okay. Okay, next is the Hesse-Bridge. Okay, the Hesse-Bridge, as I mentioned before, okay, this is good to measure the high Q coils. Okay, when the Q is over than 10, okay, then the Hesse-Bridge will be used. Okay, but normally we don't know this yet because the Lx over Rx, Q is equal to Lx over Rx is over than this, but you can measure, you can know that the Hesse-Bridge is like this, where the Hesse-Bridge here different from the Maxwell. This having a resistance, okay, R1 is series, okay. Previous in Maxwell bridge, the R1 is parallel with the C1. But for the Hesse-Bridge, when the R1 is series with the C1. Okay, so for the Hesse-Bridge, okay, the others is the same. The others is the same, where Z2 is R2, Z3 is R3, and ZX is RX and LX. Okay, is series. Okay, so to make it balance, okay, as before, Z1 over Z3 is equal to Z2 over ZX. Then you can find Z1 ZX multiplied with ZX is equal to Z2 multiplied with Z3. And each of the Z1, Z2, Z3, and Z4 is defined like this. Okay. So, so here you can substitute, okay, all these Z1, Z2, Z3, and Zx into Z1, Zx equal to Z2, Z3. You can find like this, lah. Okay. And from here, we also would like to compare with the real term and the imaginary term. Okay, where R1, Rx. Okay. So here you can find. So first, we want to break the bracket. Okay, we want to break the bracket first, and then we will compare with the imaginary term and real term. Okay, so after we break it, we can find like this, where R1 Rx plus with the J omega Lx R1 minus J Rx over omega C1 plus Lx over C1 is equal to R2 R3. This is after we break the bracket. Okay, then we can see here there is a real term and also the imaginary term. Okay, the imaginary term. Okay, so here the real term that we want, that we get, is R1 Rx plus Lx C1 is equal to R2 R3. Okay, then we can find the Rx here. So for the imaginary term, okay, Rx over omega C1, Rx over omega C1 is equal to omega Lx R1. Okay, because we change. Okay, because here is there is no imaginary term, then we make Lx R1, omega Lx R1 minus Rx over omega C1 equal to 0. Therefore, we change the side for the Rx over omega C1, then we can find the Rx omega C1 is equal to omega Lx R1. Okay, so we can get like this lah. Okay, so for the real term and the imaginary term. But in order to solve the Lx and Rx, okay, so we have here where the Rx is omega 2 omega Lx C1 R1, because we want we make it like this. Okay, we we multiply, okay, the top and the down one, and we can get omega 2 Lx C1 R1, and we substitute it into the number 1. Okay, and we make it this as number 2, equation 2, and we substitute the value of this Rx into equation 1. Then we can find that R1 Rx is, we put here this one into this one, and then we can get omega squared R1 C1 Lx plus with the Lx over C1 equal to R2 R3. Okay, so here we can get the new equation. Okay, then we can try to break the bracket, and then we can find like this. Okay, which is the omega squared R1 squared C1 Lx plus Lx over C1 is equal to R2 R3. And then by both, and then we want to get the Lx, then we want to make this, okay, times with this and times with this. Okay, and then we can find that omega squared is R1 squared C1 squared Lx plus Lx is equal to R2 R3 C1. And then we can find that Lx is equal to R2 R3 C1 over 1 plus omega 2 R1 squared C1 squared. Okay, so this is for the Lx. This is for the Rx. Okay, and this is for the Cx. But from here, okay, we substitute again the value of Lx into the Rx here, okay. So we can find that Rx is omega squared C1 squared R1 R2 R3 over 1 plus omega 2 R1 squared C1 squared, okay. So inside the Hess bridge, okay, the value of Rx is this one, and this one is for the Lx, okay. But in order to find the Q, okay, in order to find the Q, is Q equal to omega Lx over Rx, we can put the Rx inside this and Lx inside this, okay. Rx here and Lx is here, and we can find that Q is 1 over omega R1 C1, okay. So this is how you can just cancel out, okay, the bottom one, and we can cancel this one, okay, and we can cancel this. Sorry, cancel this, and we can cancel this. Okay, so ini tak boleh. Okay, so yang tinggal ialah 1 over omega R1 C1. Okay, so Q is 1 over omega R1 C1. Okay, so here we get the omega is Q R1 C1, and then we can change the Lx here into the if we want to put in Q, okay, Lx is equal to R2 R3 C1 over 1 plus 1 over Q squared. Okay, so this is another type of if you want to find the Lx based on the Q. Okay, but normally we can see the example here. Here, find the series equivalent inductance and resistance of the network that cause an opposite angle, which is the Hebrew tunnel with the following bridge. Okay, so in this example, they are given the omega is 3,000 radian per second. R2 is 10 kilo ohm, R1 is 2 kilo ohm, C1 is C1 here is 1 microfarad, and R3 is 1 kilo ohm. Okay, so to find that, so you can use the equation for the Rx, and then the equation for the Lx. Okay, equation for the Lx is this one. Okay, this one. Okay, so this one need to be remember lah, for the Rx, and then you just put inside the value, and you can find the value of Rx, and you can find the value for Lx. Okay, so therefore the Rx is 4.86 kilo ohm, while the Lx is 270 millihenry. Okay. Okay, so that's for the Hess bridge, for the Hess bridge. So the important thing is this one, the equation Lx, the equation Rx for the Hess bridge. Okay, then we go for the next bridge is the sharing bridge. Okay, and this sharing bridge is to use for the precision measurement. Okay, for the capacitors. Okay, for the capacitor where the C3, okay, is high quality mica capacitor for the insulation measurement. Okay, so in this bridge, okay, you can see that the C1 is parallel with the R1. For the R2 is the adjustable resistor for the impedance Z2, and Z3 is C3, and ZX is CXRX. Okay. And during the balance condition, this is the same with the Maxwell and the Hayes, okay, where Z1, ZX equal to Z2 multiplied with Z3. And then you can find that Z2, Z3, Y1, okay. So this is for the ZX. Okay, then after that, we know that ZX is RX minus J omega CX, and the Z2 is equal to R2, okay. And then Z3 is minus J over omega C3, and Y1 is 1 over R1 plus J omega C1. Okay, so this is the continue of this because we have the ZX, we have the Z2, okay, and we have the Z3 and Z1, and then ZX is equal to Z2, Z3, and Y1. Then we bring in the value, substitute the value of Y1, Z1, Z2, and Z3 from the previous, okay, Z2 and Z3, and then we can get this lah, okay, the Rx minus Z J over omega Cx, okay, equal to R2 times multiple with the minus J over omega C3 multiply with the 1 over R1. Okay, this is Z2, this is Z3, and this is Y1. Okay, this is the ZX. So from here, it's multiply, okay, from this multiply to J minus J, and then multiply with the 1 over R1, and then we can get R2 minus J over R1 omega C3 plus with the this we multiply with the J omega C1, and then we can get only R2 C1 over C3, and this is still ZX. And we want to compare with the real and the imaginary terms, then we can get Rx is this one, and this one is for the imaginary. Okay, so Rx equal to R2 C1 over C3, and then Cx, okay, Cx, we can get the R1 over R2, okay, because we ignore the J, and then omega is same, then we can cancel out, and then Cx is 1 over Cx, therefore we have to contra the R1 over R2 C3. Okay, so this is the value, the important equation, important equation for the sharing bridge. Okay, for the Rx equal this one, and Cs is equal this one. In the sharing bridge, there is a dissipation factor, okay, where dissipation factor is also equal to the Q, where Q quality factor is equal to 1 over D, and D is omega Rx Cx. Okay, so in this example 5.4, okay, there is an AC bridge. Okay, AC bridge, same for the sharing, where this is parallel, and this is for the C3 for the Z3. Okay, and then we the value for the arm AB, the value for the arm AD, value for the arm BC and also for arm CD is unknown. Okay, unknown for the RX and CS. So in this example, we want to determine the unknown capacitance and dissipation factor. Okay, so in order to know the dissipation factor, we have to know the value of CX and RX. Okay, so in order to know the CX and RX, so we can use the formula that we derived. Okay, RX is equal to C1 over C3 R2, and CX is equal to R1 over R2 C3. Then we can just put inside the value, and we can find that RX is 2 kilo ohm. For the CX is 0.25 microfarad. And then we can just put inside the dissipation factor equation, which is D is equal to omega CX Rx. Okay, omega is 2 pi. Okay, and then we have to find the value for the Rx. Okay, put the value for the Rx and the Tx, and you can find that D is equal to 3.1416. Okay, this is how to find the example 5.4. Okay, and now we are going for the fourth bridge for the AC bridge. Okay, in the AC bridge, this type is called Wien bridge. Okay, normally it's used for the frequency measurement. Okay, Wien bridge is used for the frequency measurement, and the features is also can measure the unknown capacitance with great capacitance with great accuracy. Okay, as you see here, okay, the circuit, the configuration of the Wien bridge is different with the others. Okay, where R1 as a adjustable resistor, series with the C1, R2 for the Z2, and R3 is the adjustable. R3 is parallel with the C3, and that is R4. Okay, for the Z4. Okay, here during the balance, okay, here we want to balance is the same, Z1, Z2, Z1, Zx is equal to Z2, Z3, and then on each of the arm, okay, is for example the Z1 is R1 minus 2 J omega J over omega C1, and the admittance of the parallel arm, okay, the Y3 is, okay, the Y3 is 1 over R3 plus J omega C3. And in order to make a bridge balance, Z1, Z4 is equal to Z2, Z3. And then we can find that Z2 or Z3 change to the admittance, and we can find Z2 over Y3. And then for the Z2 is equal to Z1, Z4, Y3. Okay, so we bring the Y3 here with the Z1 and Z4, and we can find Z2 equal to Z1, Z4, Y3. Okay, here we put the value for the R1, the R2, and also the Z1 and Y3 inside this. Okay, where this one is Z2 equal to okay, Z2 is equal to Z1, Z4, Y3. Okay, Z1, Z4, Z1, and Y3 again. Okay, so we pointer. Okay, we multiply. Okay, we break the bracket, and then we break a bracket with this one also, and we can find that R2 is equal to R1 R4 over R3 minus 2J R4 over omega C1 R3, plus J omega C3 R1 R4 plus C3 R4 over C1. Okay, so here we can bring the real, okay, the real and imaginary. Okay, this is imaginary and this is the real, and then we can equating the real we have as per like this lah. So where R2 is equal to R1 R4 over R3 plus C3 R4 C1, while the imaginary we can get the R4 W omega C1 R3 minus the omega C3 R1 R4, and then here we can find that R2 over R4, we bring R4 here, okay, R4 here to bottom, okay, we bring R4 on both sides to bottom, and then we can get R1 over R3 minus C3 over C1. Okay, the same with this imaginary, okay, we bring this into this, and then we can get plus, and then we can cancel out the R4, and then we can get the 1 over omega C1 R3 is equal to omega C3 R1. Okay. Okay, so then we can get the omega. Okay, then we get omega. We multiply this, okay, with this, and then we can get omega 2 is equal to 1 over C1 R2, R1 R3 C3, and then we can get omega is 2 pi F. Okay, omega 2 pi F is equal to 1 over C1 R1 C3 R3 squared apa root squared for the C1 R1 C3 and R3, and then we can get the C3, okay, C3 that we want to find, okay, is 1 over omega 2, okay, C1 R1 R3. Okay, this is from here, okay, this you get from here, and then this is you get from here. Okay, so then you can get the F is equal to 1 over 2 pi root C1 C3 R1 R3. Okay, so for the wind ridge, okay, the example 5.5, okay, you can find the equivalent, parallel, resistant, and capacitance that cause a wind ridge to null with the following components. Okay, okay, here C3 and R3, you want to find this. Okay, for the R1 is 3.1 kilo ohm, C1 is 5.2 microfarad, R2 2.25, and F given frequency is 2.5. Given frequency is 2.5, and the R4 is 100 kilo ohm. Okay, so here given omega is 2 pi F, F is given here, okay, 2.5, then you can get the omega is 15.71 kilo radian per second. Okay, so just you find the R3 and C3. So the R3 and C3 you can find from the value here. Okay. Tadi. Okay, for the C3 and the R3. R3 you can get from the value, okay, where the R4 over R2 times to R1 plus over omega squared R1 and C squared, and you can put inside the value, and you can get the R3 is 12.4 kilo ohm, while for the C3 is you can put again the R2, R4, C1 given, okay, and you can get the 20.3 picofarad. Okay, the important things, okay, is this one, you cannot apa kata tu, ignore during your calculation, okay, the value for the microfarad, the kilo ohm, and kilohertz, anything on that. So just don't ignore it, and you need to include it into your calculation, and then you can get the picofarad or kilo ohm. Okay, if not, you will make a mistake for the mathematical calculation. Okay, so that's 4 types of the AC bridge. Okay, we have learned about the Maxwell bridge, we have learned about the Hess bridge, sharing, and also the Wien bridge. Okay, so first you need to recognize you have to recognize the type of bridge that have been given in your, for example, in your examination. Okay, and then for example, if you see the Z1 here is parallel with the C1, or in Hess bridge is a series. Okay, and also for this is C1 and R1 and C1 is what we call it, parallel, but this is adjustable, but this one is series. Okay, so for the Maxwell, as have been mentioned before, okay, we want to measure the unknown inductance, okay, the unknown inductance and the Rx here. Okay, we want to check Rx and Lx. For the Hess bridge, also we want to find the Lx and Lx. Okay, but this one is for the high Q factor coil. Okay, and for the sharing bridge, we want to measure the C3. Okay, we want to measure the C3. C3 blood. Sorry. Okay, we want to measure the Cx and Rx here. Okay, same with the Z4. Okay, Cx and Rx here. Okay, and for the Wien bridge, we want to measure the frequency, and also we can also measure the capacitor. Okay, for the for the C3. Okay, so this is the conclusion for the Wien bridge, Maxwell bridge, Hess, and also sharing. And the important formula, okay, for the AC bridge is for the Maxwell bridge, you have to know the formula like this, where Rx is equal to R2 R3 over R1, and Lx is equal to R2 R3 C1, while the Q is omega C1 R1. Okay, same with Hess bridge. Okay, you have to know the Rx and the Lx, and then you can find the value of Q. Okay, and also for the sharing, because of you have to find the Cx and Rx. Okay, so this is the sharing bridge for the Rx and Cx, and then the dissipation factor, okay, or the quality from the dissipation factor, you have to use the Rx and Cx inside the dissipation factor equation. And for for the Wien bridge, okay, you can find the C3 is equal to 1 over omega 2 C1 R2 R1 R3, and the frequency is equal to 1 over 2 pi root C1 C3 R1 R3. Okay, so this is the important formula, okay, that can be used, that can be remembered in order to what answer the question for the AC bridge. Okay, I think that's all for chapter 5 for the DC and the AC bridge. Okay, then we can go for the next for the sensor and transducer for next week's. Okay. Silap. Okay, so that's all for the chapter 5. Okay, so that's all for the chapter 5. I think we will go for the chapter 6 for the next weeks. Okay, for the sensor and transducer. Okay, just to let you know, for the okay, so for this class, okay, basically, we have the midterm on the Thursday at 5 o'clock. Okay, 5 o'clock at BK3, yeah, BK3 in FKE. Okay, just make sure you came and bring your stationery. Okay, so the chapter will be covered for the chapter 1 and chapter 2, okay, for the midterm, okay. So just study your tutorial and also the slide that we are discussing in this class, okay. I think you can answer that all the question. Okay, I think that's all. Okay, is there any, before we finish, I would like to take the attendance. Okay, okay, good. Okay, ada apa-apa? Ada
Doctor,
apa-apa? Yes, saya.
is there the midterm cover the theory part?
Teori part. Kalau teori itu sikit sangatlah markah dia. Normally, for the examination is more on the calculation. Teori itu ada, tapi few lah, sangat sikit lah. But you have to know also lah. Okay, to get if you want to get marks, full marks. Okay, thank you. Okay, ada apa-apa ni? Ada masalah ke untuk exam hari Khamis ni petang pukul 5? Ini exam antara kita saja, okay. Tak ada ni buat orang lain sebab susah nak adjust masa. Okay. Okay, kalau tak ada tak apa. Okay, I think we can stop until here and you can start to study or what. Okay, so that's all, and we will meet for next week. Okay, I think for next week, just let you know, because I cuti minggu depan. Okay, so sekejap, saya stop recording dulu lah.